So I have some word problems from 6.7 in our book. And unfortunately, the answers in the back of the book are not correct. So I wanted to work these out for you so that you could see how they should come out and you can check your answers this way. So this is section 6.7, page 550, and I'm looking at number 29, 30, and 31. You may not have been assigned these problems, but I encourage you to stop and try them by yourself first. So pause the video and do that. All right, I'm going to do them, so hope you paused. And are you replaying it now? Well, let's figure out what we've got. A doctor's prescribing a medicine, and we've got 125 milligrams. So we've got our initial value. Plus, there is a decay rate of 30% as the medicine metabolizes. So that means we can go from there and figure out, B is 1 plus R, which equals 0.7. So we actually have our model. I'm going to let, let's see, T equals hours after we take the medicine. And so now I'm going to say D for the drug of T is equal to 125 times 0.70 to the T power. Now question number 29 says, how long does it take before half of the drug is metabolized? So I want to find time for the drug to equal 62.5. That's half. So I can solve an equation right here. 62.5 equals, and when I divide, I'm going to get 1/2 equals 0.70 to the T power. And if we do the log on both sides, I'm going to put the log of 1/2 equals, and when I do the log of the expression above it, I'll be able to pull the T out front. I'm skipping a step here for the sake of video time. And then I can get T by itself by dividing. So I'm just going to write down the answer over here. Here's the exact value. I divide both sides. I didn't show that step over there, by log of 0.70. Now there's an exact value, but it makes sense to round it off to the nearest hour like they asked. And we're getting about 1.9, so we can just say 2 hours. So after 2 hours, that medicine is half used up. Number 30, write an exponential model that represents the amount of drug remaining in the patient's system after T hours. Well, technically, we have that already. So right here is the model. We did that because we needed it for problem number 29. Then use the formula to find the amount of drug remaining in the system after 3 hours. So we have to plug in 3 for our time. 125 times 0.70 to the 3 hours. And that problem is purely a calculator problem. So we're going to get 42.875. Let's just round that off to 43 milligrams. Now that's approximate, but we're good there. Use the model found in the previous exercise to find f of 10. Now I call it D, but it's a repeat of problem number 30. So we're just going to plug in 10 for our time. So we got 10 times 0.70 to the 10 power. And when we run that in the calculator, we're going to get 3.53, and they want us to interpret that. So the interpretation is the 10. What is the 10? In 10 hours. The remaining amount of the drug is 3.5 to the hundredths, 3.53 milligrams. So there is the final explanation of that last problem. Okay, so I got a couple more of these. I encourage you to watch them all.